get started. There's only a couple of attendees today, but not a problem. Welcome to our Friday webinar. Today we're going to be continuing on custom tables. By the end of this video, you should have a greater understanding of how custom tables work and how to write them. Specifically, we're going to be creating a table that allows us to apply machining for hinges to ends and doors when we want more than 5 hinges in a cabinet. We'll introduce some formulas and create a couple of other tables in the process, which you will find useful to have. Use them in other tables. If you didn't see our first webinar on custom tables last week, it's on our YouTube channel now, and this should be up there with it by this time next week. Today we're using CabMaster Pro version 12. It's now released to all customers with customer care. If you don't have the update showing, contact support. As with last week, we won't be doing questions through the webinar today. Custom tables can be increasingly complex, and we won't have time to go through all the other options that could be applied. You can leave the webinar at any time by clicking on the red phone button at the bottom of the screen. As I said earlier, we are jumping right into writing tables today. If you need more background on how custom tables work, you can watch the previous webinar video. The end result of today will be a custom table that adds hinge and plate machining for when you want more than 5 hinges in a door, or if you've got a floor standard cabinet normally with 2 hinges, but you don't want all your other standard cabinets to have, say, 3 hinges in a door, you'll be able to add a 3rd hinge. To start off, let's just add a circle to a left end. Now there's 2 ways to do this. We could apply a shape and radius the edges, similar method to last week with the rebate. We can plot each corner with X and Y values. The easier way to add a circle is to specify a diameter, a depth, and a center position from the bottom left edge. Now a quick recap, the bottom left corner is 0, 0. A positive X value moves our center to the right, and a positive Y value moves our center upwards. Codium X is the far right edge, codium Y is the far top edge. So codium X minus 50 millimeter would be 50 millimeters back from our right hand edge. And that's to the center of the hole. Same goes for codium Y. It'd bring it down. So we open up the machining custom folder, which is where I am now. Now I'm going to open up sample. You can just double click on that. If it doesn't open with table editor, right click, then choose open with and select table editor.exe. We can see that there's 6 lines in this table being used. Now, in total, lines 1 and 10 are for custom boring, and 11 to 20 are for shapes. And as we can see here, we can use both boring and shapes in one table. That explains why in last week's webinar, the LED strip rebate started on line 11. So what I'm going to do is copy and paste this table. And we'll do that with right click, copy, and paste. We're going to rename this to pass-through. So the first thing we're going to do is a cable entry pass-through for whether it's, say, a washing machine or a dishwasher in a left-hand end. And that puts it just there. So we'll open that up. In line 1 for the use column, we have 1 as that's on, 0 is off. And what I'm going to do actually is select everything in there. I just hit the delete button. Nice fresh blank start. We can even copy that line if we wanted to, so we can make it all uniform and just make them all nice and even the same. You don't have to do this. They can be blank if you're not using those lines, but I like having everything look nice and neat and the same. So one in there because we're going to use line 1. Layer is the name that gets exported to EasyNest or NRoute. It's what actually determines how this will machine when it gets to the CNC. For now, I'm going to enter cutout. It needs to be in quotation marks to work. Press tab and we'll go across to the next line. So the diam is diameter. It's the diameter of the circle. This can be entered as millimeters, centimeters, inches. CabMaster can work it out. It can handle it. If you are using a measurement that isn't millimeters, put it in brackets. As this pass-through is for a power plug, let's make it say 50 millimeters. Click tab. Depth is how deep we want it to go. We can enter a specific depth, but if the material changes, then it will always machine to that same depth. Again, a pass-through needs to cut through. To ensure that it does cut through, whether the material is 16 mil or 18 mil, we can enter dim 3. Now, if we try and enter dim 3, while this is set as length, it shows up as error. We need to make sure that we change the column type to string and go dim 3 there. So dim 3 is just thickness of material. Now we get into positioning the hole. The X and Y values work from the bottom left corner of the part. So if we open up bottom left corner, and it goes to the center of the hole. So if we set our X and Y as 25 millimeters, it would butt the circle right up to the bottom left hand side and bottom. So it would put the circle right in this corner, touching both of those edges, because 25 mil is the radius. So we'll do that here, 25 millimeter tab. Make sure it's going to type in 25 millimeter tab, 25 millimeter, click tab. Repeat quantity is how many times do we want the circle to repeat in a regular pattern on either X or Y axis. In this case, we only want one circle, so we'll put in 1. And the last thing we need to do is put 1 in the Z column. Excellent. So we can go File, save that. There's our new table. Close that down. So if we apply that to a cabinet, we open that up, we go to custom and left, it pops up this window here, and we choose our new table pass through and tick it on, apply and OK. And as you can see, it puts it right in the bottom left hand corner because ends machine from the inside face. So say we want it up in the top corner of the left end, so up here somewhere. Close that. Go back to dimensions. Instead of having it 25 up and 25 across, we're going to go code in minus, code in minus. Open up our table again. Into here. And we want it in a little bit more, so we'll make it say, not do dim, it'll be code dim. Minus 25, except we're going to go a little bit more, 50 millimeters. Tab, and again, that needs to be a string, so we'll need to re-enter that, and we'll make this one a string while we're looking at it. codim x minus 50 millimeters, and this one will be codim, did I spell that right? No, I didn't. Codim y minus 50 millimeters. Now we can grab these or double click on them just to move them across so we can see exactly what it's doing. It's all nice and readable. Double check so we're turned on. The layer name is cut out. It's 50 mil hole. It's going right through. It's 50 mil from the right end and 50 mil down from the top. And we only have one hole. File and save. Close that. Always close a custom table before you double check that it's working in CabMaster. So if we go back to there, open up this, it hasn't moved yet. So what we'll do, we'll refresh our drawing and we should see it move up to the top. There it is there. And that will apply machining. If we look at the machining and left, click on there, we can see that it goes 16 deep and the layer is cut out. Generally, cutout is going to be set up as a layer and strategy in EasyNest or NRoute. If you're using that, it will just do an internal cut rather than an external. So that should go to the CNC and cut perfectly fine. So we'll close that down. Now we could use, or we could enter code into the use column. I'll bring that table back up. So instead of that being 1, we could say enter a code that decides whether it's a left hand or a right hand and when to use it. And of course, we can change all that stuff. That's very easy to do. We're not going to do it in this table. We're going to now start working on our next table. So we'll take what we already know with adding a single hole and alter the table to put 2 holes for a hinge plate. So I'm going to copy that one, paste it in there, and we're going to rename and then call this 6th hinge. And it will move it up the top when we open that up. This will always open on your main screen. So our hinge plate is going to be 2 8mm holes spaced 32 millimeters apart and set back from the front edge of our end 37 millimeters. We're going to base this on the Bloom hinge pattern, whether it's headache, whether it's the inline hinge plate. So you can't actually see the hinge plate behind the hinge. It's all much the same, it's just different dimensions, different X and Y values. So the first thing I'm going to do for our hinge plate is change the diameter to 5 millimeters. Click Tab, and then change our depth to 13 millimeters because we don't need it to go all the way through the board. And of course, we should probably change our layer name to something that is more likely to machine with a 5mm hole or a 5mm drill on CNC. So we'll change that to hinge plate. You could use hinge 5mm, you could use screw 5mm. It depends on what your EasyNest NRoute has associated with that layer name. And again, it's got to be in quotation marks for it to work. We'll tab across. Now we know that the X needs to be 37 millimeters because that is 37 across from the edge or the left edge. And the Y value, I want to work off local property number 6. So if we open up drawing properties, and I should have had this here ready to go, in job setup, and local properties. In my setup, I want to make sure that I've got 6 on. Now I'm going to leave that as X6, so every time we look at it, we know that we're looking at local property number 6. Back in the table, again from last week, local property number 6 is DefIn 6. Now, because we're going to the center of the hinge plate and our 2 holes are spaced 16 mil apart, 32 millimeters apart, center to center, we actually need to set our first hole as center of the hinge minus 16 millimeters. So we go DefIn 6 minus 16 millimeters. Now, so we can get 2 holes spaced 32 mil apart, we need to change the repeat quantity to 2. And as we're repeating it on the y-axis, we can skip repeat x and change repeat y to 32 millimeters. We'll tick that. So once you've made sure that local properties is on in CabMaster, table saved and closed, we'll open up our cabinet details. In here, we can either enter it in here at a cabinet level, or we can do it at the drawing property level. Through job setup, you see now we've got that option there. I'm going to set this one at 300 millimeters. It can be whatever you want, obviously. I'm just doing this for demonstration. Close that. I'm going to, while I'm here, go back to our 3D wireframe view and then go to custom. Now in our end left, we still have pass-through applied. I'm going to change that, and I now want it to be the 6th hinge. Apply and OK. And there's our other hinge plate right there. And it is 300 up from our bottom edge of our end to halfway between those 2 holes. So if we look at that in machining, end left, the bottom one should be 284, and we can see it's set 37 mil back. So that one's going to be 316. 5 mil diameter, 13 mil deep, and our layer is hinge plate. Now this is obviously only going to work on the left end. If we applied it to the right end, which I'll do now, it's going to put it at the back of the carcass, which is not what we want. So we'll go to 3D wireframe. You can see there it's done it there. It's put it at the back. Now we know about codim x minus, etc., etc. So that's what we're going to use to make this work. So we're going to start another line. Just going to go 1. Actually, what I will do, we can copy and paste lines. So I'll grab that, Control C, in line 2, Control V, copy and paste. And our x value will be codim x minus 37 millimeters. Double click that so we can see the whole thing. Now, obviously, because we've got use 1 and 1 on, it is going to apply both hinge plates to whatever part you apply it to. So the next thing we do is make sure that it only applies the one we want on the left hand, and then it only applies the hinge plate that we want for the right end to the right end. We can do this with changing the use column to string instead of whole number and entering a formula in there. So in line 1, we're going to put if open bracket, sec part name equals apostrophe ENL apostrophe close bracket, then 1 else 0. Now this needs to be absolutely spot on. If it's not correct, it won't work. We'll click tab and we'll just move that across. Now if that one's for the left end, we want this one to be the right end, so we just change that L to an R. So that's if the section part is an end left, then on, otherwise off. And line 2 is if a section part is a right end, then 1, or then on, otherwise off. We can file and save that. Exit that. Back to CabMaster, FN, and F5 on my laptop will recalculate. And there's our 2 hinge plates just there. Now I'm going to turn off the right end because we don't need it on. I'll just untick it. It's probably the easiest way. So I think that's pretty awesome. We have a custom table that can apply an extra hinge plate at whatever height we want it within the cabinet. Now we just need the hinge. Now the hinge is much the same. Again, we're going to place it on the bloom pattern with 8mm lugs. Simple changes could be made, whether it's for headache or any other hinge plate and cup pattern. So we'll start with the hinge cup. We'll open up our table again. Excellent. And in line 3, I'm just going to turn it on. Go across, and straight away we'll use Hinge Cup as the name. It makes it nice and easy to recognize. And it's going to be 35mm. That's pretty standard. And our depth will be 13mm. Now I know the hinge cup for a bloom hinge by default is 21mm, 21.5mm to the center from the edge. And our Y, because we are just going to the center of the hinge cup, that can be DefIn 6. Now we're only repeating one of these, so we're not repeating it, which means the only other thing we need to do is put a 1 in the Z column. So this is going to work for a door hinged on the right. So we can copy and paste line 1, line 3 into line 4 and change our X value. Keep hitting the D instead of the C. Codim X minus 21.5mm. And now we have one for our left door. Now to make sure that they only apply to the door that they're supposed to be on or to the hinge side that they're supposed to apply to, in the use column, we can enter something like if open bracket hinge me on equals apostrophe right apostrophe close bracket, then 1 else 0. So that's saying if my hinges are on the right, then on, otherwise off. And we can actually copy and paste that again. Control C, Control V. Get rid of right and put in left. And now we have our left door. So we'll save that. And now if we go back to CabMaster, so there's our hinge pattern there. There's our codes. We open up our cabinet and we go back to 3D wireframe. In our drawer front or door, we'll turn on 6th hinge, tick, apply, OK. And we have to wonder where we have gone wrong. So I have entered something incorrectly. This is why it's absolutely vital to get all these codes correct. And it is hinge me on right, hinge me on left, then 1, else 0. $35mm, CodeM, DefIn 6. That is all correct. We've got that as that, and that is that. File, save. Are we missing anything else? I don't believe so. Exit. Back to there. FN F5. There we go. There it is there. You can see how absolutely vital that is. A capital N versus a lowercase n, and possibly a refresh. We'll fix that. So now we've got a hinge cup. All we need is our 2 hinge lugs. So it's much the same process as the hinge plate, just obviously applied to the doors. So we open up our table again, and straight away we can essentially copy these 2 lines, Control C on the keyboard, Control V, and straight away we're going to change these to hinge lug. Control C and Control V into there. Now these are 8mm, but they're still going to be 13mm deep. Control C and Control V. Now the hinge lug spacing, we close this for a second. Our hinge lugs are 31mm. So we can change that one quite easily, 31mm, and that'll be CodeM X minus 31mm. Now, that is also going to have to be DefIn 6 minus a set value so that they off center. So if we go back to CabMaster, we're 45mm center to center on our hinge lug, so it's 22.5. So we'll use the DefIn 6 minus 22.5 minus 22.5 millimeters. We can copy that into there. Now we're going to be repeating this. So we'll repeat it twice, or repeat them twice on the y-axis, and they're 45mm apart. So now we have that. We make sure all these are spelt correctly. Save that, close that. Let's refresh our drawing. Open it up. I'm going to fix this up because that is driving me crazy. Back to 3D, Y view, and there's our hinge with our hinge lug. We can move it around with this value here. So we'll make that 400 tab, not 44, 400 millimeters tab. You can see it's moving around. Once we click apply and OK, and do that, zoom out, then see that it moves around, and it moves the hinge and the hinge plate. So this will work as long as we don't have door gaps. If we change our bottom gap, because it all works off the bottom left, to 20 mil, we'll see that our hinge cup no longer aligns with our hinge plate. Now this is where we can use another bit of code, door gap bottom, in our custom table. I'll open this back up first. If we hover over this, that code came from door gap bottom. So where it says enter length in this edit box for door gap bottom, that's just where we get it from. So we can open that up in our table, go to there, and we can change the Y value again by adding, or minusing I should say, door gap bottom. Click on tab. We can save that in there. File, save, close that, minimize that, back to here. I'm going to get a nice good angle of it. Refresh our drawing once more. And of course, we didn't do it for the hinge cup itself, we just did it for the hinge plates. So this is our hinge cups here, so we can also go minus door gap bottom. File and save, exit, minimize that, back to here. Refresh the drawing once again. You can see our hinge cup moves to line up with our hinge plates, and it now accounts for a door cap at the bottom. So you could use this as an overhead if, say, you've got a under panel and your door hangs down 20 mil or so, not 200. It will all still line up perfectly. So where this becomes really useful is if you're doing a 6th hinge in a cabinet. In a universal, you see I've got one here that I prepared earlier. We've currently got our 5 hinges, 1, 2, 3, 4, and 5. We want another hinge here. If I go to cabinet details, hinge 2, you can see I've already spaced them, and they are spaced 440 mil apart. So my 6th hinge is going to be 1420 plus 440. We'll add that as we want in the fronts. And we've got 6th hinge, that one there, apply and OK. You can see that it's added them down there already. And we'll add them to our end left and our end right. Now you can also set these up in a system table, which means they'll be there automatically if you wanted them to. We're not going to cover that today. And apply. We've got our hinge plates. Back in cabinet details. Now we can set the height for our hinges, and that is 1420 millimeters plus 440 millimeters. Click on tab. I possibly didn't calculate that correctly, but anywho. You can see that we can then position our hinge plates wherever we want them. Now, you could make a copy of this table, call one left, call one right, and then you could have completely alterable hinges. You could make another copy, use a different local property, and then you could have 7 hinges and have them all adjustable in different locations. Next week, we're going to be looking at another custom table for hinges that goes into more depth. And we can achieve something like this, where we can determine a preset number of hinges. And it will just add them in and evenly space them. And our top hinge and our bottom hinge are calculated based off in Hinge, where our tops and bottoms are 200 there and 200 there, tab, and it recalculates based off this space between the bottom hinge and the top of the cabinet. So that's something to look forward to for next week. Thank you all for tuning in this afternoon. I hope you have a good weekend, and we'll continue on next Friday.